Wonderful. Hello guys, welcome to our SMIC4 tutorial once again, and welcome to our topic, Binomial Theorem. Remember our hashtag, you don't need to be a scholar to get an A. This is the part 4 of Binomial Theorem, and in this part 4 we are going to be looking at more examples on the Binomial Theorem. Now let's look at this beautiful example. It says find the value of the term a raised to the power of 3, b raised to the power of 3 in the expression this if a is equals to 1 over 3 and b is equals to 2 over 3. Now in the part 3 of binomial theorem, we looked at how to find the coefficient of an expression of an expression. In this case, we are looking at how to find the value of a term in the expression. So this a raised to the power of 3, b raised to the power of 3 is a term. So we are looking for the number. We are asked to find the number attached to this term. Is that okay? Now let's look at what this says. It says in this case of having two algebraic variables in the binomial expansion, the exponent of the second variable is usually taken as r. So ordinarily, seeing this, you just know that my r is equals to the exponent of b, which is 3. Is that okay? Now why is that? This is the reason. A raised to the power of 3, b raised to the power of 3 is a function of the general term a raised to the power of n minus r, b raised to the power. You know our formula. In our formula we have a raised to the power of n minus r, b raised to the power of r. So if we say a raised to the power of n minus r and b raised to the power of r, and we have an expression to be a raised to the power of 3, b raised to the power of 3, we can see that this exponent of a, which is 3, is gotten from n minus r when we have n minus r, but the exponent of b, which is 3 here also, is gotten from the value of r. So we can see that we can just take the value of the exponent of b as the value of our r. Do we understand that? Yes. So having known that, now let's continue our question. Now applying this general formula, now we should know that our n is equal to 6 from this expression a plus b raised to the power of 6, right? Now our r, as we've gotten, is equal to 3, and our a is given to be 1 over 3, our b is given to be 2 over 3, and our n minus r, of course, is equal to 6 minus 3, which is 3. Now applying our general formula, which is n combination r, and so on and so forth. Our n is 6, so we have 6 combination here, 6 combination 3. Our a is 1 over 3, that's why we have 1 over 3, because this is n minus r. The value of n minus r is 3, that's why we have 3 here. Then b, the value of b is 2 over 3, and the raised to the power here is 3, so we have 2 over 3 raised to the power 3. Let's clean our slide so that we can be able to solve better. Now 6 combination 3, you know it will give 6 factorial over 6 minus 3 factorial 3 factorial. Now what happens here to give this? What happens is that if we have 1 over 3 raised to the power of 3, it means, and assuming we also have 2 over 3 raised to the power of 3, what you just do is just this one will be raised to the power of 3, 3 will also be raised to the power of 3. So 1 raised to the power of 3 is 1, 3 raised to the power of 3 is 27. We get that. 2 raised to the power of 3 is 2 times 2 times 2, which is 8, and 3 raised to the power of 3 is 3 times 3 times 3, which is 27. Not 9, not 3 times 3. It's 3 times 3 times 3. Do we get that? Yes, very good. So what do we do here? We just do 1 times 8. 6 factorial will give us 6 times 5 times 4 times 3 times 2 times 1. But because we have 6 minus 3 equals 3 factorial, and we have 3 factorial here, we want to cancel the 3 factorial. So we stop at 3 factorial, and this 3 factorial cancels one of these 3 factorial. Is that okay? So we have 6 times 5 times 4. 6 times 5 times 4. Then this 3 factorial becomes 3 times 2 times 1. So this 3 here 1, 3 and 6 will give us 2. 2 we cancel this 2. What remains? 5 times 4. 5 times 4 or will give us 20. Okay, so what we have left, let's clean our slide. Let's clean it up. Now, 5 times 4 is 20, so it will be giving us 20 times 8 over 729. So this 20 times 8, 20 times 8 will give us 160, and that is it. We have the value of this term in our expansion. So the value is 160 over 729, which is our answer. I hope you all understand this wonderful question. Now let's look at this wonderful question which says, find the term of x squared in the expansion of that. The term of x squared in the expansion, in this expansion. Now to find the term of x squared, what do? We must first find the value of r. Yes, because we're not giving r here, we can't use 2 as our r. So we must first find the value of our r. Now what do we know from the question? We know that n is equals to 8. And we also know that a, which is our first value, is equals to 2x, and b is equals to minus 1 over x. And n minus r will be 8 minus r, because we don't know the value of r. Now applying our general formula in solving this question. So we have 8 combination r, we don't know r, then 2x raised to the power of 8 minus r into bracket minus 1 raised to the power of r. Now what do? In this case, we have minus 1 over x. We can separate minus 1 over x in this way. So instead of having minus 1 over x, everything raised to the power of r, we can break it down into having minus. So what we are doing here is that we are bringing minus 1 out. So minus 1, anything we bring out must carry the exponent r. So we are bringing minus 1 out with the exponent r, and we are leaving, remember we've taken minus 1, so what are we leaving? We are leaving 1 over x. We are leaving 1 over x. We are actually bringing minus, but minus cannot stand alone, so 1, right? Okay, so that's why we have 1 over x raised to the power of r. So that's why we have this here. So we are breaking this into this. Now let's break this also, cleaning up. Let's break these also. So we have 2x in brackets raised to the power of 8 minus r. So meaning that these 2 and x both have these exponents. So breaking them down, we can pick 2 and, of course, take the exponent with it, which is 8 minus r, and we also can pick x, and also it will take the exponents. Why? Because of the bracket telling us that it's both 2 and x that has what? That is in possession of the exponent 8 minus r. So breaking down, you will see that it gives 2 8 minus r. This dot, of course, means times x 8 minus r dot this and dot that. So you see, we've broken them down. Now what do? From the above, we simplify the term in x. Simplifying the term in x is that we bring all those terms here that has x. So the first one is x minus r, and the second one is 1 over x. So we do that, and that's what we brought them out here. Now bringing them out here, we can see that we have x raised to the power of 8 minus r and 1 over x. If I have 1 over a can be simplified to give a raised to the power of minus 1 from indices. If I also have 1 over a raised to the power of, say, n, this will give me a raised to the power of minus n. So meaning if I have 1 over x raised to the power of r, it will be simplified to give x raised to the power of minus r. And what do we have here? We have x raised to the power of 8 minus r. So we can say x raised to the power of 8 minus r. From your law of indices, we know that once we are multiplying, this exponent becomes plus r. Is that okay? Plus minus r, plus minus r. Plus minus r will give x. Let's clean up this. Now from this, we know that this will give x raised to the power of 8 minus r, and we know from the law of indices that once we have times, the exponent will become plus. And what do we have here? Minus r, so minus r. Is that okay? So we have x raised to the power of 8 minus r, then plus minus is minus, which is minus r. and minus r will give us minus 2r. That's why we have 8 minus 2r. Now let's continue in solving. Now we quote it to x raised to the power of 2. Why are we picking x raised to the power of 2? Because of the question. So we are equating x raised to the power of 2 to what we got, x raised to the power of 8 minus 2r. Is that okay? So in following our exponential rule in exponential equations, we know that x will cancel x and it will remain 2 equals 8 minus 2r. And solving this, simplifying this, we know that it will give 2r. This will give us 2 minus 8, and this will give us minus 2. This will give us minus 2r. Dividing both sides by minus 2 by minus 2. So minus 2 cancels minus 2 here. R is equals to 2 minus 8 is minus 6. That's minus 6 divided by minus 2. And minus 6 divided by minus 2 will give us 3. Plus 3, because minus cancel minus, which is plus. So the value of our R is equals to 3. So now, since the value of our R is 3, and we know that from our formula we have the R plus 1 term. To find the term, we can see here that is R plus 1 term. So we just do r plus 1, which is 3 plus 1, which will give 4. So the term of x raised to the power of 2, we can see is the fourth term. I believe we all understand this question, and I believe we all found this video informative. Thank you for watching. Thank you for listening. You can practice with these beautiful questions. Practice so that you can be very, very perfect in this topic of binomial theorem. In our next video, we are going to be looking at examples involving fractional exponents. Thank you for watching. Thank you for listening. Make sure you subscribe to our channel for more, and tune in for the part 5 of binomial theorem. Thank you.